Hello and welcome to yet another episode of Quest, the weekly inter-school science quiz brought to you by the National Council of Science Museums and 𝐿 Kendra, Kolkata. As before, scientific questions and experiments brought to you by Mr. G.S. Rotela, who's the director of Nehru Science Centre, Mumbai. Let's have a big round of applause for him. Hello, sir.
Oh, yeah.
Feel rested, sir?
Yes.
Great. The team's here today, the J.C. Bose team, and you are?
I am Supratik Das from Birla School. I am in class 12.
Yes.
I am Gunjan Bhattacharya from Birla School. I am in class 12. I am Shobhik Mukherjee from Birla High. I am in the same class.
Well, I would have imagined you all from the same school. And on my left, we have Loreto Day School, Sealdah. That's the C.V. Raman team. You are?
I'm Radha Biswas from Loreto Day School. I'm in class 11.
I'm Shubhasri Ghosh from Loreto Day School. I'm in class 11.
I'm Vidya Mukherjee from Loreto Day School, Sealdah. I am in the same class.
Okay. I trust all of you know the rules. They're fairly simple. 7 questions in all. 4 are direct. 3 are on the buzzer. The direct questions carry 20 points each if you answer them within 15 seconds. 10 points on passes. If neither team answers, we go into the audience. Buzzer questions are plus 20 and minus 10, and they do not pass to the other teams. So remember, when you hit the buzzer, you must have those answers ready. Let's not waste any further time and get on to the very first question, which is for the J.C. Bose team. Well, J.C. Bose team, if you're ready then, we have the very first experiment for you, Mr. Rotela.
Yes, the experiment that I'm going to perform for you is, there's a triangular railing which is inclined, and I'm going to experiment with 3 different solids. One is double-ended cone, one is this ball, and one is a cylinder. Now the question to you is, which of these solids going to climb up the hill or up the rail when I put them at the bottom, and why?
Your time has begun. Hurry up, J.C. Bose team. I'm afraid your time's up. Well, girls from C.V. Raman team, do you have an answer? No, they do not. Audience, well, we have a lot of takers from the audience. Yes, why don't you come up? Milind, weren't you on one of our shows earlier?
Yeah.
Yes, why don't you come this side?
The double-headed cone, ended cone will climb up because its center of gravity is in such a position that it attains equilibrium position and hence the most stability when it climbs up uphill.
Let's see what he says is right or wrong. Yes, he's right. Let's give him a big hand. What's going to happen with the other 2 pieces?
The other 2 pieces, their center of gravity is placed in such a position that they will tend to slide down or remain constant at that position.
Let's see what happens. The cylinder, it doesn't go up. Let's see what happens with the ball. It too goes up. So you are partially right. But now tell us what exactly is happening.
Basically, the center of gravity is in such a position that if it is here, then it has the equilibrium position and does not tend anymore to go downwards.
But tell me whether really it is going up or not, the CG.
No, the CG is remaining constant. The CG is just attaining a position in which it has the most stability.
Will it be lower or upper than this position, the CG?
In this position, it is upper.
How? Why does it come down then?
So because in this case, the CG comes down, so it stabilizes because in this position, the CG is placed in such a way that it does not have the maximum stability. If it comes up here, then the CG is placed in that manner stability.
Very good attempt, and I would like to add to his answer is, the center of gravity, which is very important for stability of a solid, in this particular case, comes down. You know why it comes down is because the rails are opening up and the solid goes down. So as a result, the center of gravity comes. Whereas in case of a cylinder, there is no chance for the cylinder to go in the rails, between the rails. As a result, the center of gravity remains along the axis of the cylinder. And whereas in case of a cone and a ball, the CG is at higher point at this location and goes down here as it goes inside the rails. So CG is going down. All right? Thank you very much.
Well done, Milind. We have a small memento for you from Quest. Thank you. Would like to add to that, Mr. Rotella?
Well, I have already told you that the center of gravity is going down in case of cone and ball, whereas in case of cylinder it's not possible, as it remains on the rail all the time. And the ball and cone is going inside the rails as the rails open up in diameter in the gap between them.
Is this same principle used for lifting any heavy object uphill or rolling something? Would you suppose in the olden days when they made pyramids in Egypt, is that the way they rolled?
Well, that's what they could have done, and it is possible to do it. And it's one principle you can give advantage, but it happens only when you have a circular shape and of the body, not with the cylinders or with the, and very difficult to carve out stones much heavier,
Yes.
and to make them cylindrical or double-ended or spherical to take them up the rails.
Okay. Well then, no score to either team. The next question is for the C.V. Raman team. Both teams yet to get off the mark. No score to either team. C.V. Raman, here's your question.
I have a can which is empty, and I have two loads, two spherical balls made of brass, quite heavy, and attached to a rubber band. And in stretch condition, I am putting on the top of this. Okay? Now I lift this can up and drop. What do the balls go in?
It is because when you are stretching the rubber band and putting the two spherical balls in both the sides, then the balls are in the state of inertia of rest, and when you are moving up the tin can, then the ball tries to be in a state of rest as well as the tin is in motion, and so it drops down.
Why? Why do they drop down?
Because everybody tries to remain in a state of rest or in motion.
No, that's not quite correct. Would you like to try?
Yes. The balls, actually they are removing the support. The tin was the support on the balls when you are stretching the rubber band, and balls want to maintain their inertia of rest. The rubber band between the balls makes the ball come closer, and the ball, when the tin falls, the ball remains for some time without the support of the tin, and so the balls come closer and it falls inside the...
Not quite correct. Would you, anybody in the audience would like to try? Yes?
Yes, Gaurav, please come up. Hold the mic.
It's because the balls, when they are in the stress condition, when the tin is allowed to fall off, the ball, now in this case they are not in stable equilibrium, and they are not in the least potential energy condition. So when the tin is allowed to fall off, the rubber band, it tries to come together, and
Why?
because elasticity, and they need to come to the least potential energy in the stable equilibrium condition.
That's not a quite correct answer. Would anybody else try to add to this his answer? Well,
Yes.
it's quite simple. I would like to tell you this. When they are stressed, the rubber band is under stress because of this heavy load, and is in this position. When I am dropping it whole together, the two loads, the rubber band and this can, what happens in a free fall? The load loses mass, loss of weight. It's a free fall condition. So when there is no load, the stretching of rubber goes, and the rubber comes back to its recoiling position and takes the loads in. Okay? That's what a simple answer. So any free fall condition, the weight becomes zero. All right? That's what. So there is no stretching possible for rubber. So rubber recoils back and brings back the loads inside. And it's necessary for this. The rubber band has to be smaller than the diameter. Okay? So it comes back and both the loads fall down. That's what the correct answer.
Is that, Mr. Rotella, the reason why we feel a sense of weightlessness when a lift goes downwards?
Yes, that's true. That's true. When the lift comes with a high speed downwards,
Yes.
especially multi-story buildings, you feel weightless because you tend to lose weight when there is a free fall.
Well, let's have a big round of applause for Mr. Rotella.
Yeah.
Nice question there. Well, both teams yet to score. We'll be back with the third question shortly. moving forward in our show today, we get into the very next question, which is the third question. That's for the 𝐺𝐶 team.
Well, take one rubber band in your hand, all of you. The simple experiment is you stretch it slowly, bring it back, slowly again stretch it, bring it back, and stretch it and put it on your forehead. Do you find any change of temperature? It's cool. Now, next experiment, part of experiment is you pull it rapid and put it on the forehead. Do you feel it's hot? It's hot? Okay. The question is, when you pull it rapidly, why does the temperature rise of the rubber band? Not in case of very gentle pull.
Well, when the rubber band is pulled rapidly, the work done by the rubber, the energy increases in the rubber band, energy content, and there is no time for the energy to be released.
Yeah.
And so the temperature of the rubber band increases, and so when we put it against the forehead, it...
But why does the temperature rise up? Not, and that doesn't happen in case of when you are gentle in pulling.
Well, we do it fast. I mean, it is done pretty fast, and as a result,
you can add a little bit. You are very close to the answer.
The molecules of the rubber, they gain they get the kinetic energy, and thus.
What I would give you 20 points, but you have to add is when it is rapid, there is no exchange of heat taking place with the surrounding. Whereas in case of gentle, it's possible to exchange the heat, and the temperature does not rise up. All right? Okay. I would like to add one more. So they get 20 points anyway for this. So a big round of applause. But I would like to add to this, when you are stretching the rubber, what are you doing? You are bringing the molecules to order. In case of rubber, they are disorderly, so entropy is high. So when you are bringing it to order, the entropy comes down. But in case of adiabatic expansion, they call it sudden adiabatic exchange of heat or a process. There is no entropy change. But how does in this case, how do you explain it? How do you really explain the change of temperature? It should not have happened. Well, it's called unstable equilibrium condition, because stressed rubber is never in equilibrium, whereas entropy, no change, the equilibrium should not be disturbed. Okay, in this case, equilibrium is disturbed because you have stressed the rubber, which is in tension, under tension, right? So it's not an equilibrium. That's why the entropy in this case cannot be same.
20 points to you, 𝐺𝐶 team. Well done, Gunjan. Well done, Shouvik. Next question is the direct question, the last of the directs. That's for the C.V. Raman team, who have yet to open their account. We'll be back shortly.
Well, I am sure this time you are going to get 20 points. It's a very simple question for you. I have a glass. I'm going to push a cloth inside this. And I have a beaker with water. What I'm going to do is push the glass with the cloth inside. See what happens. This cloth doesn't become wet. The question is, why not?
The water doesn't get into that glass because the glass originally contained air, and when it was inserted into the water, the air could not get out, and so the water did not get up in the glass. If the air
You
was
are
out,
absolutely right. So she gets 20 points, wins 20 points for a team. Well, air gets compressed to some extent, but not to that extent that water can push it and come out of this glass. So that's the reason the cloth didn't get wet. That's
20 points apiece. The next of the questions is on the buzzer. Welcome back. You're watching Quest, the inter-school science quiz brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. We are over and done with 4 questions, which were the direct questions. The next one is on the buzzer. Remember, teams, in the buzzer section, we have got 3 questions in all. Plus 20 if you get it right, minus 10 if you get it wrong. these questions will not pass to your counterpart team. Mr. Rotela, you seem to have a very interesting toy here for us.
Yes, but this very interesting scientific phenomenon that works with this toy.
Okay.
So they have already pressed.
Yes.
There is ether in that
Yeah.
in that space in the duck, and there is water in the cup. When the mouth of the duck is covered with felt, when it gets wet by water, and the water evaporates, and there is ether vapor in the space in the tube, and also in this empty space in that flask shaped thing.
Okay.
So when the water evaporates, it takes the heat from the body of the duck, and as a result, the ether vapor in the tube condenses. But the ether vapor in that space below exerts a pressure in that ether, which therefore rises up through the tube.
Why does it exert pressure?
Because the vapor.
You are very close to the answer. Yes, try again.
Come on, Subhashri, you can do it.
The ether rises through the tube, and where the head becomes heavy, the center of gravity shifts and it tilts.
Yeah, that's absolutely right. But tell me, why does the ether rise up?
Because the ether vapor in that flask shaped thing.
Condenses.
Yeah.
But why does make the ether to go up? Where is the force coming from? When the water evaporates, what happens here? A clue to you.
It becomes lighter, and so the water vapor from the lower side moves up.
Why lighter means what in your terms? By weight or what?
No, not by weight, by pressure.
Yes, that's what the answer I was looking for. Let's get them 20 points.
Well done, Vidya.
Okay, so what exactly happens when this head of the duck is wet and it evaporates water, the water gets evaporated, as a result the pressure falls inside this, and because heat is taken from inside. So when the pressure falls down and from bottom the liquid rises up to fill up, equalize that pressure. As soon as liquid rises, reaches to the head, it becomes heavier and dips. When it dips, the tube at the bottom opens up, comes out of the liquid, and the liquid from the top again flows back, because there is a gap and for the vapor to go up. So it comes down, and as a result the bottom becomes heavier and the second cycle starts.
Well, now you know what's the literal meaning of wetting your beak. That duck seemed to keel over, Mr. Rotela.
Oh, exactly. This is the process happens in our pitchers. Water gets cool because it gets evaporated, and the heat is taken from inside the pitcher, and the temperature of the water falls down. And of course, pressure cannot fall down because the pitcher is open from the top.
Well done, girls. You pick up 20 points, move on to 40 points, and we go into the next question, which is also on the buzzer.
Well, the question for you is, there are two candles inside this container. One is small and one is big. If I cover the container, the question is, which one is going to extinguish first?
JC Bose team?
Tell me the answer.
Larger one.
Larger one. And let us see what happens. And then you have to explain.
It's open from this side.
Not look at.
Larger one's
You're
gone.
right. Larger one has extinguished. Tell me why.
It is because the smaller one is now still getting the supply of oxygen, and oxygen is a supporter of combustion. But the larger one is at a higher position, so the oxygen gets depleted first over there, and it's converted into carbon dioxide.
Not bottom.
Well, the column of air above the larger one is smaller, so it contains smaller percentage of oxygen in it, while that above the smaller one is...
Anything carbon dioxide has to do here? Well, they get points, but the question is, some is missing in your answer. What happens to the carbon dioxide? What does it do?
Well, the carbon dioxide envelops the candles so that no further supply of oxygen is possible, is there for the candle to.
It's for both the candles same.
Yes, but the column of air above the larger one is smaller.
But you can get supply from outside. What is the main extinguishing factor here? What gas plays the role for extinguishing?
Come on, Shovik, simple answer.
Carbon dioxide.
Then why does carbon dioxide is up, which is heavier than air?
Anyway, you've got the points, is that right?
Yeah, they get points.
Girls, do you have an answer?
The warm air rises up,
Yeah.
and the carbon dioxide remains at the top, and so the larger candle first
That
extinguishes.
was the answer we were looking for. But their first answer that larger one would extinguish was correct. So that's for that they get 20 points.
20 points. Let's have a big round of applause for them.
But you need to add what she said, that carbon dioxide being hot rises up, doesn't remain at the bottom, being heavier than air. That was the answer I was looking for.
Welcome back to Quest. Both teams running neck to neck, 40 points each. Let's see what happens in the very last question. Which team wins? Which team goes ahead? Over to you, Mr. Rotella.
Well, this question for this time is with the toy. There is a top which is spherical at the bottom and flat at the top, and there is a stem. If I rotate this top or spin this top on the top of this table, let's see what happens. Why does this turn over? That's the question. Once again, spherical portion the downward direction. If I rotate this, why does this turn over?
10 seconds to go, hurry up. I'm afraid we are out of time here. I guess we left the top B. Anyone in the audience? Nobody in the audience wants to try? Nobody wishes to try. Mr. Rotella, you'll have to explain.
The spherical portion which is at the bottom, initially it spins on the surface. There is a friction between surface and this. And this friction gives rise to another friction called sliding friction because it is spherical, it is not a pointed surface. That sliding friction at the center of mass of this top, which is the lower side, creates a torque. And that torque helps it to turn over. That's the only simple answer for this. Because the center of gravity is lower in lower half. And because of the surface is round, there is a sliding friction. The sliding friction gives rise to a torque at the center of mass of this top, which makes it to turn over.
Neither team daring enough to go for the buzzer. Content to stay where the scores were, that's 40 points each. And we are at the end of today's show. Well done, girls. Let's have a big round of applause for them. A small memento from Quest. No winners and no losers in our show today. But then, that's what this wonderful show is all about. It's more aimed at imparting education rather than creating a competition. With that, we come to the end of today's show. Both teams tied at the very same scores. That's JC Bose team on 40, CV Raman team also on 40. We hope you enjoyed watching our show today. If you want to write back to us, please write to us at the following address, that is Quest, care of Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week with 6 fresh faces, that's 2 new schools. Till then, it's goodbye from all of us.